For decades, the moon has kept its secrets, even during the golden age of the space race between the US and the Soviet Union, or through NASA's iconic Apollo missions. But now a new race is unfolding, and this time it's not just America's story. China, with its incredibly ambitious space ambitions, is opening a new era in lunar exploration. However, what's truly remarkable here is not just the landings themselves, but the discovery of strange craters hidden beneath the moon's dust, containing scientific mysteries that could completely change the future of humanity. In 2019, Chang'e WUFO made history by becoming the first spacecraft to successfully land on the far side of the moon, an area completely hidden from Earth's view. Even more importantly, China is quietly planning a crewed mission to the moon by 2030, with the goal of establishing a permanent presence on the moon. So what exactly are these craters? Why are they so important? And why is China investing billions of dollars to conquer these craters? All these answers lie within this video. Watch until the end, and don't miss the moon's secrets that have never been revealed before. In January 2019, China etched its name into the history of space exploration with the groundbreaking Chang'e 4 mission. This was not just a successful lunar landing, it was the first time in human history that a spacecraft had touched down on the far side of the moon. This bold achievement didn't just demonstrate China's growing capabilities in space. It set a new standard for future missions. To overcome the massive communication barrier posed by the moon's far side, China launched a game-changing piece of technology, the Chang'e relay satellite. Strategically placed at the Lagrange point L2 in the Earth-Moon system, a gravitationally balanced location allowing the satellite to remain in a stable orbit. Chang'e became the essential bridge for data and control. It received signals from Chang'e 4 on the far side, relayed them to Earth, and sent commands back across the void. Soon after landing, the U-22 rover began transmitting the first high-resolution images and scientific data from the far side. Revealing a landscape unlike anything seen on the moon's near side. Gone were the wide, smooth plains of ancient lava known as mare. In their place was a terrain covered in a thicker crust, scarred by countless ancient craters. Evidence of billions of years of relentless asteroid bombardment. The contrast was striking, and it immediately raised a profound question about the moon's birth and uneven geological history. How could two sides of the same celestial body, shaped by the same solar system, be so vastly different? Scientists began to suspect that the moon's internal structure is asymmetrical. and that its hemispheres cooled differently. But the real shock came with the discovery of mantle material. U2 identified rock samples believed to have originated from deep within the Moon's mantle. Forced to the surface by massive ancient impacts. This marked the first direct study of material from beneath the lunar crust. These samples provided an unprecedented window into the Moon's internal composition, lending critical support to the Big Splash theory of lunar formation. It was as if we were finally peering beneath its surface, into the very engine room of its creation. Even more surprising was the detection of younger than expected volcanic rocks on the far side. For decades, it was widely believed that lunar volcanic activity had ended billions of years ago. But this new data hints that the Moon may have remained geologically and thermally active far longer than previously imagined. Especially on the far side, this finding shakes the foundations of lunar science. It hints at undiscovered geological processes. Suggesting that the Moon is far more dynamic and complex than previously believed. China has emerged as a pioneer in uncovering and confirming the existence of resources that could completely reshape the future of energy and even life on our planet. One of the most exciting and potentially transformative of these discoveries is helium-3. Helium-3 is a rare isotope of helium, virtually absent on Earth due to our thick atmosphere shielding the planet from solar winds. But on the Moon, exposed to the solar wind for billions of years, helium-3 has been steadily deposited and preserved in abundance. What makes helium-3 so compelling is its promise as a clean, non-radioactive fuel for nuclear fusion reactors. Just 1 ton of helium-3 could theoretically power an entire major nation for a year. And the Moon? It's believed to hold millions of tons. China's Chang'e 5 mission, which successfully returned lunar samples to Earth, did more than confirm the presence of helium-3. It also unveiled a completely new lunar mineral previously unknown to science This mineral, named Chang'e, is a transparent, colorless crystal smaller than a human hair, and it contains traces of helium-3. This discovery not only showcased China's rising scientific capabilities, but also offered critical clues about how helium-3 is stored within the Moon's geology. Understanding its mineral host opens the door to future extraction technologies. But it's not just about energy. Water is the fundamental key to life, and perhaps the most precious resource in space exploration. While past NASA missions like Clementine and Lunar Prospector had hinted at frozen water in the Moon's polar regions, it was China that delivered direct and expanded evidence of lunar water. Chang'e 5 confirmed the presence of actual water molecules, chemically bound in a hydrated salt mineral known as ULM1. This wasn't just indirect evidence like hydrogen signatures. It was the first direct detection of full H2O molecules. What makes this even more groundbreaking is where it was found. Not in the shadowy extremes of the poles, but in the mid-latitudes of the Moon. This challenges previous assumptions and suggests that water might be far more widely distributed across the lunar surface than we once believed. In the same time, China, alongside other international space agencies, continues to confirm the presence of ice deposits at the poles, especially in the South Pole. These regions, with their capacity to retain ice, are now seen as top candidates for future lunar bases. Water isn't just vital for sustaining astronaut life, it's also a crucial raw material for deep space exploration. Through electrolysis, water can be split into hydrogen and oxygen. The hydrogen becomes rocket fuel, and the oxygen can be used for breathing or as an oxidizer. This means future missions could tap into lunar resources to produce their own fuel and life support. A process known as in situ resource utilization, reducing dependence on costly resupply missions from Earth. Test to Water opens up the possibility of self-sufficient moon bases habitat where astronauts can live, conduct science, and prepare for even more ambitious journeys to Mars or beyond. For years, scientists have relied on high-resolution satellite imagery and topographic data to analyze the Moon's surface. Now, in-depth studies, including data from Chinese missions alongside those from NASA and JAXA, have confirmed the existence of massive hollow chambers beneath the lunar surface. These structures have been identified as ancient lava tubes, formed billions of years ago when the Moon was still geologically active. The process that created them is similar to what we see on Earth. Molten lava once flowed beneath the surface, and as its outer shell cooled and solidified, it formed a hardened tunnel. When the lava flow either stopped or diverted, it left behind a long, hollow tube. But what's truly astonishing is their immense size compared to similar structures on Earth. Thanks to the Moon's weaker gravity, only 1/6 that of Earth, these tubes can span hundreds of meters in diameter and stretch for hundreds of kilometers without collapsing. They are, in effect, natural caverns on a colossal scale, a potential labyrinthine network waiting to be explored. But these lava tubes are not just empty voids or geological curiosities. They could be the perfect natural shelters for human habitation, a gift from lunar geology to help us overcome the Moon's unforgiving environment. The lunar surface is an incredibly hostile place. Posing serious threats to any form of life. Without a thick atmosphere or a protective magnetic field like Earth's. The Moon is constantly bombarded by deadly ionizing radiation from galactic cosmic rays and high-energy solar particles. Prolonged exposure to this radiation is known to cause severe health risks, including cancer and damage to the central nervous system. However, deep within the lava tubes, the thick rock walls can act as a natural radiation shield equivalent to several meters of soil, offering astronauts protection far beyond what any surface-built structure could currently provide. The Moon's surface is also frequently struck by micrometeoroids, tiny fragments of comets and asteroids that travel at incredibly high speeds. Despite their minuscule size, these impacts can severely damage equipment, destroy infrastructure, or even threaten astronaut safety. The lava tubes offer passive physical protection from such threats. serving as a durable barrier for both humans and technology. The surface of the Moon experiences extreme thermal swings, rising to around 120 degrees Celsius in direct sunlight during the day and plunging to minus 170 degrees Celsius at night. A staggering difference of nearly 300 degrees Celsius. Maintaining stable temperatures in surface habitats requires complex and energy-intensive thermal control systems. Inside the lava tubes, however, temperatures have been recorded as remarkably stable, hovering around 17 degrees Celsius. That's an ideal environment for human life and technological operations, with little to no need for artificial climate control. One of the most remarkable moments of the Chang'e 4 mission was the sprouting of a cotton seed, the first biosphere experiment ever conducted on another celestial body. Inside a small sealed container known as the mini lunar biosphere aboard the U-22 rover, Chinese scientists placed cotton seeds, rapeseed, potato, yeast, and fruit fly eggs. And then something extraordinary happened. A single cotton seed sprouted. Becoming the first green life to emerge on an alien world. Though the tiny seedling survived for only 9 days, ultimately succumbing to the moon's extreme nighttime cold, which can drop to minus 170 degrees Celsius and cause the heating system to fail and the plant to freeze. Its short life proves something profound. We can grow life on the moon. In 2019, U-22 made another discovery that ignited scientific intrigue and public fascination. a patch of mysterious gel-like substance on the moon's far side. As the rover traversed a small crater, it captured images of a glossy, oddly textured material with a dark green, gel-like appearance. The images triggered a flurry of speculation. Was it the residue of a meteor impact, a sign of ancient microbial life, or perhaps something even more extraordinary? Years later, in 2021, the world was captivated once again when U-22 spotted what appeared to be a mystery hut on the distant lunar horizon. Blurry images showed a cube-shaped object standing alone on the barren landscape, resembling an artificial structure. Yet in both cases, science stepped in, not to spoil the mystery, but to explain it with clarity and discipline. The so-called gel was later identified as impact melt glass, a mixture of lunar regolith and rock fused by intense heat from a meteor strike, forming a smooth, dark-colored, glassy material. As for the mystery hut, it turned out to be just a strangely shaped rock, its unusual silhouette amplified by camera angle, distance, and sunlight, creating the illusion of a structure from afar. These explanations don't diminish the wonder, they enhance it. They remind us that the pursuit of knowledge is driven by curiosity, by our relentless desire to understand the unknown, even when the answers are more ordinary than we might hope. Such moments of mystery, whether resolved or left open, are part of the grand story of exploration. They inspire us to keep looking upward, to keep asking questions, and to remain in awe of a universe that continues to surprise us. China is forging ahead with bold plans to establish a permanent presence on the Moon. Through the construction of the International Lunar Research Station, ALRS, and upcoming Chang'e missions, including Chang'e 7 and Chang'e 8. This isn't a short-term effort, it's a long-term, multi-phase strategy aimed at building a sustainable robotic and eventually human foothold on the lunar surface. The ILLRS is not envisioned as a temporary outpost, but as a versatile, expandable, and self-sustaining research facility, a cornerstone for humanity's next step into space. Missions like Chang'e 7 are targeting the Moon's south pole, where permanently shadowed craters are believed to hold vast reserves of water ice. This mission will conduct in-depth surveys of local terrain, resources, and sunlight conditions to identify the most suitable site for a future base. Following that, Chang'e 8 will serve as a technology demonstrator, testing critical infrastructure for lunar construction. Including 3D printing using local materials like lunar regolith, and developing efficient solar energy systems to withstand the Moon's long day-night cycles. Together, these carefully sequenced missions form a methodical roadmap toward a sustainable human presence on the Moon. A crucial, non-negotiable factor for sustaining any lunar base is in situ resource utilization. is RU, the ability to use local materials rather than transporting everything from Earth at astronomical cost. Currently, it can cost tens of thousands of dollars per kilogram to launch material into space. ISRU technology could allow astronauts to extract oxygen, drinking water, rocket fuel, and even construction materials directly from the moon itself. The discovery of water molecules in early minerals at mid-latitudes, abundant ice deposits at the poles, helium-3, and a host of other lunar resources provides compelling evidence that the moon could, in time, supply nearly everything needed for survival and self-reliance. ISRU will form the backbone of all lunar settlement efforts, transforming the moon from a resource-draining destination into a supportive partner. It will be the compass for long-term development. This vision of lunar habitation is no longer exclusive to China. Other nations are accelerating their own efforts, led by NASA's Artemis program. Artemis aims to return astronauts to the moon, particularly the South Pole, and establish a long-term, continuous, and sustainable presence. International partners like the European Space Agency, ESA, Japan's JAXA, and innovative private companies like SpaceX and Blue Origin are contributing advanced landers, orbital platforms such as NASA's Gateway Station, and breakthrough technologies to support this unified mission. The convergence of these global efforts signals that lunar settlement is no longer a solitary dream. It is a shared human destiny. The first glimpses of lunar life may begin with small outposts, shielded by thick layers of regolith or nestled within natural lava tubes. These underground bases will offer critical protection from harmful space radiation and extreme temperature fluctuations. Inside, closed-loop life support systems will recycle air and water with high efficiency, while space agriculture, using hydroponic and aeroponic techniques, will supply fresh food, reducing dependence on Earth-based resupply missions. "3D printing with lunar regolith will enable on-site construction of essential infrastructure. Lunar life will represent a unique fusion of cutting-edge scientific research, strategic resource utilization, and deep space technology testing. A proving ground for our next great journey outward into the cosmos. The strategic competition between China and the United States is an undeniable driving force in the current race to the moon. The U.S. views China's rapid rise in space as a challenge to its status as a technological, military, and political superpower. This has led to massive investments, widely publicized milestones, and a cautious, sometimes suspicious, attitude toward sharing sensitive technologies or engaging in official collaboration. China, with its swift development and ability to independently carry out complex missions, makes no secret of its ambition to become a leading space power. It is building the ILRS as a potential counterweight to U.S.-led initiatives, establishing its own path into space. While the U.S. and China are leading the charge in lunar exploration, did you know that many other nations are also actively involved, achieving remarkable milestones? Despite clear competition, science continues to be a universal language that transcends political boundaries. Data from China's lunar missions is shared with the international scientific community, contributing to our collective understanding of the Moon. The technical challenges and enormous costs of deep space exploration demand collaboration, shared burden, and combined expertise. Next-generation rovers are being developed to tackle extreme environments and complex terrains never before explored. NASA, for example, is developing duaxle, a rover capable of splitting into two independent units that can maneuver separately or reconnect to traverse treacherous terrains like deep craters and steep cliffs that traditional rovers cannot access. Future missions will require the ability to bore tens or even hundreds of meters beneath the moon's surface to reach ancient geological layers and search for evidence of the moon's complex geological history. Samples retrieved from such depths will offer unprecedented insights into the moon's composition and the processes that shaped it. China's role in this new era of space exploration is undeniable. It has demonstrated perseverance, long-term vision, and exceptional engineering capability. Opening new horizons for all of humanity. These discoveries carry immense significance, not only for space science, but for the future of humanity beyond Earth. They affirm that the moon is an essential foundation for our extraterrestrial future. We now stand at the threshold of a new era, where lunar settlement and resource utilization are no longer distant dreams, but achievable and necessary goals. The moon is not merely a laboratory, it is a strategic stepping stone on our journey into deeper and more distant space. Can humanity rise above political divisions to reach for the stars together? The answer lies in how world powers choose to shape this race. Will it become a battle for dominance and resources, or a constructive race to expand the boundaries of knowledge, life, and human potential? Our future in space depends on that choice. It is a reminder that Earth is not our final limit. There are countless unknowns still waiting, ready to be discovered. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.